Hi, everybody. I apologize for everyone who's heard this joke already, but this is a very large room for a very small Arrow implementation. So, yeah, thank you. Thanks for that. Yeah, that's good. So my name is Dewey Dunnington. I work for Ultron Data, and this is I feel very lucky to have this be part of my job. I work on all things Apache Arrow. We'll talk a little bit about what that is in a moment. But one of the favorite things that I got to do for work over the last little bit is write a C implementation of Arrow with a number of contributors and put some Python bindings and some R bindings on top of that. And this is a session about playing nice across languages. And I think that nanoarrow to me is one of the projects that really speaks the most to that mantra, because it's really about trying to play nice, to try and get data from one language to another, from one Python package to another, no matter what language you're using to do your implementation, or what language you're binding you're using for your glue code. So before I talk a lot about Arrow or nanoarrow, I want to talk about some sort of three motivating use cases that nanoarrow ended up helping to solve, but it sort of wasn't clear what to do before we were when we had started these projects, and we sort of weren't sure exactly what to do. So one of them was the Snowflake Python connector. So Snowflake is a database. It's an excellent one. And they are pretty committed to getting Python users a really fast connection. So they really want to make it really easy to get their data. When you issue your query, they don't want you to wait when you get your data into Python. So they have this protocol, this wire protocol. So the bytes that they send over the internet to get your data to you is in something called Arrow IPC. And it's this nice representation. It represents all of their types losslessly. But it doesn't necessarily, it's not exactly what people want out necessarily. So there's some transformations that have to happen. There's some compute stuff. And because they want this to happen very quickly, they implement that in C++. So they're implementing the C++ code to take Arrow stuff, to take these tables, and give you what you want as a user. So Arrow C++ is a great way to do that, and for a long time it was sort of the only way to do that if you wanted to do high-performance Arrow stuff. But unfortunately that resulted in a pinned version, because you had Arrow C++ in PyArrow and you had Arrow C++ in Snowflake, and you had to make sure that they matched up with each other, or you'd sort of end up with a crashed process. So this is sort of one of the issues. We want to do Arrow stuff, and we want to do it really fast, but we don't really have a really good way to help us with all the details. And so another one this is like the nearest and dearest to my heart, and how I got into this, into Arrow really, is geospatial data. So like geospatial compute functions are awesome. And it's really nice if you can implement them very quickly, and there's a lot of really great libraries to do it. But if you want to write some function that does some transformation, so like I can do this fast thing here, then you have to get your data sort of into your package, your new Python package that's nice and fancy, and you have to get your data out at some point. So the act of getting your data in and getting your data out is something that you really don't want to take up extra time. So this is the example that I'm going to use is parsing something called well-known text. But this guy right here, it's how pretty much everyone writes their tests. Some databases will give you this back. There are a lot of places where you have gigabytes and gigabytes of this stuff, and you need to parse it very quickly into something that can actually be understood. So there are lots of C libraries that will do this for you. And as I'm sure Kyle will correct me in a moment, there's lots of REST ones that can do it too. But we're going to talk about the C one for now. And so I basically wanted to write this function, and I love writing parsers. It's one of my guilty pleasures. So I did this thing, I wrote this parser, but I needed to get my data in, and I needed to get my data out, and it was unclear to me how to do that. Strings, and especially lots of strings, are not something that, that Python has historically done very well. And finally, I want to talk about QDF. So this is NVIDIA's data frame library. It can do not just geometry stuff really fast. It can do geometry stuff really fast. It can do like everything really fast. And if you attended the talk yesterday, you will sort of know how fast. It's very fast. It's a very useful library. And it's honestly one of the coolest things that I've participated in, even though I was just reviewing code and stuff. But they basically need to get stuff into their package, do their fast thing, and then get it out. And they don't want the getting it in process or the getting it out process to be the bottleneck. Like, they're trying to make things faster, and they don't need the process of getting something in or out to make it worse. And QDF also has the advantage that it's sort of already Arrow friendly. And I haven't talked a lot about what Arrow is yet, and apparently I have one more slide before I got to that point. It's the wrong transition. But it's all these packages, all these problems are all really getting at the same problem, where it's like you need to get an array, a table, something from one runtime or package to another. Like in the GeoArrow case, like we can't put geospatial functions sitting in PyArrow or any of these general purpose libraries. It's a pretty big problem, and there's a lot of really huge complexities that are better suited to being handled by like a separate package. So we have to have it somewhere else, and because we have to have it somewhere else, we have to have this link. So I put this picture in lieu of actually making a proper circle in Arrow's diagram. It's a switchboard, a telephone switchboard. So like you've got something coming in, you got a call coming in on one line, and you need to connect it to something over here. And you as the user, developer, you're trying to connect these wires. Like we are all just connecting wires and pipes all the time. And it's a lot easier if those wires and those plugs are the same shape every time. And so if you have this wire, you've got this plug and it fits here and it fits here, then you can get your data from one place to another. And I'm not here to tell you that Arrow is the one and only way to do that. There are a lot of ways to get your data from one place to another that have like been designed and tested and tried and true carefully over a long time to make sure that this problem where like you want to send data from one place and you want to do something over here and send it back, that problem has been thought about. So in Python, I don't know if anybody's familiar with the Python buffer protocol. It's this generalization of a NumPy array that works at a very low level. So it's implemented in the core of the language. And so it can be very fast when you have one Python package that operates on some ND array over here, and it can send it back, and it can do it without copying, and it can do writable stuff, and it's very cool. It's great for integers and floats and packed structs and a couple of other things, and probably something someone's going to correct me on at the very end of this talk. But it can't do strings particularly well without having a lot of Python objects. It doesn't send anything to the GPU. And there's no like straight up way to serialize it and open it in something that's not Python. So if you want to take this ND array, and there's lots of things that will serialize an ND array, but the buffer protocol it's not really in scope for that. So if you want to do all of that, but you want to do it on the GPU, you can use this thing called DLPack. So DLPack is another one of these plugs that it's like can be well understood. This consumer and this producer implement these very specific protocols. And you can have them understand each other, and you as the user don't have to think about how to plug these wires in. You have this DLPack-shaped wire, and you plug it into your switchboard, and it gets your data from one place to another. And that place could be on two GPUs or a GPU and a CPU. It's pretty flexible. So that's great. It doesn't have a way to do strings, as far as I know. And it doesn't deal with this nested data problem. So sometimes you just have a list of stuff. Every row has a list of IDs or something. The data frame protocol solves the string problem, but it doesn't yet do nested data. I'm sure that it could, or will eventually, or maybe it does now. It didn't when I started this talk. But it doesn't do ND arrays, and it doesn't do serialization, really. It's a little bit limited in scope. And of course, we have Arrow sitting here over on the side. And I'll talk more specifically about which types of Arrow and things that I'm talking about. But it is a protocol. It's an arrow-shaped wire that you can plug into one side and plug back into the other. And it will get your data from one place to another. And it includes integers and floats and strings and dates and times and maps. And it has a very wide-ranging type and an extensible type system. So it can represent just about anything, which is great. And it also has a serialization defined so that you can, when you hit the edge of your process or you hit the edge of your internet, your network, you can send it to bytes and send it somewhere else. And this is a talk about multiple languages and playing nice. And Arrow has an implementation in all of these languages. I purposely left a blank screen for the rest of them because I didn't want to get yelled at for saying that it's not supported in all these languages. And I'm sure that it is, but it's just not native to those languages. So you might write some Go code that interfaces with Python, and you can use the Python buffer protocol to get your data in. But you're not writing Go code independent of Python that uses the Python buffer protocol. If Python's not involved, it's not something you would reach for. And Arrow is something that you can reach for. There's a Go Arrow implementation. There's one in Java, C#, and I'm missing some languages, I think. I think I very specifically missed C and C++ here. So there's basically, if you want to send this arrow-shaped, you have this arrow-shaped wire, and you want to plug it in on the end, there are a lot of plugs that have already been written for you. And that is a very powerful thing. And the fact that that plug doesn't have to be another Python package that's using bindings in one of these languages. It could also be something written in Java sitting in a Docker container over on the side here. So Arrow is just this, it's this toolkit, this format, this shape of plug that is incredibly flexible. And it's really what nanoarrow is trying to do. So if there were another line that said C there, then that's sort of what nanoarrow would be. Oh, so there's also some ecosystems that spread beyond just like GDAL has bindings in all languages, and DuckDB has bindings in many languages. And these are also things that have an arrow-shaped plug. So if you are writing something that like does some really fast and cool computation, or this really cool file reader, or this really cool file writer, your data has to get there somewhere. And if your plug is shaped like Arrow, you can plug it directly into one of these things. And they're basically, I'm trying to show with this 2 slides that there's a lot of things to plug your wire into. It's a big switchboard. So I do want to talk a tiny bit about what Arrow is. And instead of going over the entire mantra of what Arrow is, I want to go into one very specific problem that it solves. Until recently, and it was presented very nicely at this conference, how NumPy deals with shipping strings. But until recently, dealing with, like, if you had like a billion strings or something, putting them all into Python was expensive. Like, you had to have a list of strings. And that is hard we heard in the last talk that there's like a GIL problem, like you're accessing Python stuff. So you have to worry about Python memory a little bit. You have to worry about GIL stuff a tiny bit, depending on what you're doing. And in general, it's sort of just generally been thought of as a slow process. So Arrow has a way to do this. So the arrow-shaped plug for strings involves not just one buffer, but a couple. And that's sort of, in general, how Arrow has chosen to deal with this problem. It says, OK, we don't need just one buffer to represent all these types. We need more than one, a couple. So for strings, it's 3. You have one talking about whether this thing is or is not null, which can be missing if they're all not null, very common. And then you have one that contains all of the strings smushed together. So if you have, we'll look at an example in a second. It's a couple of fruits. This is all those data just sort of smushed together. And then we've got some numbers that tell us where each one of those things starts. And that is one way to represent a whole bunch of strings. It's not the only way Arrow has to represent strings, but it is a very common one and a very useful one if you wanted to do something like ship a string array into some awesome package over here that can do a search algorithm and then ship your answer back. So what nanoarrow actually does is it's really sitting here on the edges and helping you doing the creating process and the consuming process. So basically, we really want people to make arrow-shaped plugs. And nanoarrow is a really easy way to do that. So if you have a couple of strings, and they're Python strings, and you want to make them into this nice multiple buffer format, that's like this awesome shaped plug that you can plug into some Java implementation sitting somewhere else, nanoarrow will do that for you. It'll pack these things into like one big arrow array and ship it. If you want to read them, it will do the same thing. So if you have this wire over here, then you can be an arrow-shaped plug over here that can consume these things. And maybe what you want is the Python representation of that. And so it will happily read those out for you and give you your little Python string list, if that's what you want. If you can assemble those buffers better than we can, if you can do it faster and better because you have some awesome Rust or C++ library that does it better, you can just take the buffers and put them together yourself. And that's a pretty powerful thing to do. And if you want to head the other direction, and what you're looking for is you receive one of these things, and you have some really fast thing over here that just understands one or two of the buffers, you can also just get them. It doesn't mind. It doesn't have to extract every single one of those Python strings if you don't want it to. It just can. And finally, a very powerful thing that it can do is if you have this stream, the stream of bytes, the serialized form that came from an internet connection or something. Maybe you have some Lambda function running that got data from a Snowflake app, and you want to serve it via HTTP. Then nanoarrow will read that for you. It has a reader for one of these things, and the the PR is open as we speak. And so I've shown you the Python bindings, which are relatively new, and the C stuff has been around for a little bit longer. And I won't go too far into the C, and I feel a little bit bad about showing C, but I've been told that it's already been shown at this conference. But this is what it might look like. So you've got your banana, orange, and apple sitting here. And it's pretty verbose. It's C. We have to handle the errors. I didn't skip the error handling or memory management here. And there are some C++ helpers to make it a little bit less bad. But in general, it will get you these things. So if you're binding a C library that has some of these these really fast in-out things, then it will help you do that. It's similarly, it'll read these things one at a time if you want it to. And if what you have are a bunch of vectors, maybe you had some really cool thing or some library that worked with the standard library, you can ship those standard library sequences as arrow arrays if you want to. And headed the other direction, I couldn't come up with a good example off the spot about why you'd want to do this, but if you have some really awesome algorithm that just needs those buffers in isolation, it doesn't need every single item, it just can understand arrow already, then you can get those and ship it to whatever you're working on. And yeah, so now I want to circle back to some of these motivating use cases. So Snowflake, one of the main things that they were using it for is reading that stream of bytes. So they serve up their query result, your query result, when you send it to Snowflake. They serve it up as this really efficiently packed binary form of bytes, and nanoarrow can read that. And so they vendor nanoarrow, the C library, into their package. They no longer need the Arrow C++ library, which was doing that before. So nobody has to pin PyArrow's version anymore. And they can do what they need to do, and they can provide you a really fast way to get your results once you hit Python. And I have this link to the slides at the end. You can click into these if you're really interested in the examples here. GeoArrow, again, this is like one of the things that I love doing. I love writing parsers. So I wrote this well-known text parser so I could write tests for all my geospatial compute functions. And so it takes this array of the strings. It takes this arrow array of strings. It does its computation. It builds up some buffers, and then it assembles them again and ships out arrow. So it solves this a billion strings are still in Python problem by taking an arrow, doing its transformation, and shipping out arrow. That also means that I can reuse the same C library in R and Python. And R is one of the first languages that I started writing. It's how I got good at writing C code. And so it still holds a near and dear place to my heart, so I try not to write too much that can't be used for both. And so this is a really great way to do that. And finally, in QDF, they implement every type. So they have like an incredibly wide, incredibly rich type system. So they're trying to get everything in, and they're trying to get everything out. And so they have to do a lot of like type things. They have to inspect types, map some types in Arrow to map some types in there. And they're incredibly committed to getting these in and out be incredibly fast. So I was told minutes ago that they're using this to get, at least in the upcoming version, they'll be using it to get the host data to the GPU and the GPU data out. And their data is already mostly in Arrow format already. So it was very easy for them to just assemble these buffers, because they had the buffers already sitting over here, and they just assemble them in this standard plug format so that they can plug their data in, and their users can integrate it into their workflows like even better than they can now. And finally, I just wanted to go over some of the a sort of key difference between the Arrow C++ and PyArrow ecosystem and the nanoarrow ecosystem. So Arrow C++ is amazing, and it can do anything with your arrays. It can cast them from one type of array to another. It can read Parquet files. It can write Parquet files. It can read a lot of Parquet files and query them and filter them and pretty much do anything that you need it to do. nanoarrow sort of leaves the transforming up to you. And as a result of leaving the transforming up to you, it nixes an incredible amount of complexity. So all that nanoarrow will do is help you make arrow things. Or, given some arrow things, it will help get you out of arrow things to what you need to do. And very importantly, it ships as 2 files. So there are a couple more files if you want to do IPC reading. And we also support the standard CMake and Meson and all that. But in general, you can slap 2 files into your Python package, and it will build pretty much anywhere. And so that is pretty much what I wanted to talk about. I'm sure I missed a lot of things in the scope of doing all of this. But there are a link to the slides here. So this is linked here, dewey.dunnington.ca. And if you wanted to check out a little bit about nanoarrow's repo, it's right here. And we also have a website with the render documentation and all that. So thank you very much.
All right. Thanks for the talk. Do we have any questions in the room? Okay. Hard to see. Thanks for that.
I don't have any nanoarrow stickers, although they would be cool. I've made the hex logo.
Okay, I got 2 questions. The first one was just an understanding point of view. When you explained about the buffers, I understood the purpose of the 2 of them, but the binary one, why is that one also needed? Could you not imply the null data from like the one that specified the start of each string?
Yeah, that's a great point. And the answer is it probably could have been done that way, but it wasn't. So they could have done something like put a negative value or something in there. But I think that there are a lot of reasons why it ended up that way. But in general, all arrow nullability is represented by a separate buffer. So it doesn't matter whether you have integers or floats or whatever. Like it doesn't use a sentinel value like not a number. It uses a separate thing that's saying this thing is or is not null. And you can just omit that if everything is not null. So it's very efficient for non-null data, and it's very compact for stuff that does have nulls because it's 1 bit per element instead of 1 byte per element.
Okay. And then, yeah, second question is, obviously, you said like nanoarrow is essentially just 2 files, but what's the saving in terms of like, I don't know, when you compile it, how small does that file compare to the other one? Or
yeah, so nanoarrow's Python wheel is maybe a good indication of that because it compiles all of nanoarrow. I test everything, and so it ships it all. It's like 1.5 megs or something, and that might be high. Yeah.
But what's Arrow for reference?
I don't know. It's 150. Oh, I don't want to get in trouble for saying how big it is.
Yeah. Okay. All right. Thanks.
Do you have any other tips about when you would want nanoarrow versus arrow? I mean, I'm assuming if you just need to consume the arrays, is that the big savings, or are there other?
Yeah. So the nanoarrow really shines if you are trying to wrap a C library, and if you're writing some file reader that's wrapping some I don't know, scientific C library or something. That's where it really shines, is doing that, and then having nanoarrow Python on top of that, helping you get that data in and out of regular Python land and print it and test it. nanoarrow for Python can help you if all you're doing is consuming a table or consuming arrays. The second that you have to do something like filter, you're out of luck. So that's where you reach for PyArrow. Also, reaching for PyArrow is fine for most people in most cases. In that circumstance, it's a great library. It installs very big, but hard disks are big, and it's not that big when it's compressed. So it's really good for the create and consume thing, and it's really good for testing all of that. But it really shines when you're using the C component of it, for sure.
I think I could add to that that it's not so much the size, the disk size of the dependencies. Hard drives are big. It's the dependencies of dependencies. When you're installing PyArrow, it's fine because the PyPy package or the Anaconda package it'll take care of it. But if you need Arrow as a C++ dependency, it gets pretty hairy because it has a lot of pieces that depend on. It's not easy to plug in a C++ dependency, but just dropping 2 files in, that's very attractive.
I will add to that, dropping 2 files in is very attractive. I won't deny that. I did that on purpose, and I worked pretty hard to keep that working in CI. I will say that building nanoarrow or building Arrow C++ without any dependencies is actually very fast and very easy. It doesn't give you a very big one. The problem is that then you can't ship your Python package and have it run alongside another version.
Any more questions? No questions online? I don't see any hands. So maybe we'll finish with another round of applause.